the future is incredibly bright. I think we've barely scratched the surface of what conversational AI can look like. I think, again, the elbow, right, so to speak, of like the for voice AI has just been like so steep. It feels like, we're on the up, but like I'm so confident that there's going to be just another pivot that's just going to like
Oh,
increase the
really?
slope again. Sonic 3 is the fastest, most controllable text-to-speech model on the market. It's the first model that allows you to
Bold statements.
It is a bold
statement.
It is a
Yeah.
bold statement. Transformers are not computationally efficient at these very long context lengths,
Right.
but these state-space models are.
Uh-huh.
And when you think about applications like audio or long context videos and images, things like these, it makes sense that you don't want to keep every piece of context around, right? You're trying to just generate based on what information you have about the global state as well as what you've just generated to figure out what are the next things that come about. Yeah,
He will now be featured. Hey, Dad.
Hey, Ron.
Yeah, can I talk to you? I'm here with Arjun,
Hey, Uncle. Cartesia founder.
Oh, hey.
Nice to meet you.
Let's maybe talk a bit later.
Okay.
All right, sounds good. All right, bye.
Yeah.
All right, that's a fun start to this edition. Anyways, so welcome here we're calling the podcast Skywatch.
Nice. Okay.
Little play on Blue Jay.
Yeah.
But we're super excited to have you.
Yeah, thanks for having me.
Plan is to just drive around the city for a bit, interview you, talk to you, see your story, how you started Cartesia a little bit. But if you want to kick off things, tell folks, a little bit about yourself.
Yeah.
Yeah, go for it.
Sweet. Yeah. Well, no, thanks for having me. Really excited to kind of jump in here.
Yeah.
So yeah, I'm Arjun, one of the co-founders of Cartesia.
For sure.
We're building the future of like interactive machine intelligence.
Okay.
Right? So how do you think about machine learning more from building these systems that interact with humans?
Cool.
Not just like, run on some monolith cloud, right? And then you kind of sense things to it and then hope things come back.
Yeah.
I mean, like, a bit about me. I think I've just generally been very fascinated with the place where like machine learning meets a lot of the applications that we have. And so like spent a lot of time actually early in my career in ML, but in like healthcare. So I was just
That's I did a deep research about you
Oh,
before
yeah?
this thing. It was like Arjun won the best award for some paper in the healthcare space.
It was a long time ago. Yeah. Actually not that long, but I think the reason I was just so excited about it was like, typical story, right? Dad's been in engineering for a while, done some really awesome stuff there. And then mom's a physician.
Yeah.
So I was like, oh, this is threading the needle, right? Perfect.
Yeah, no, you had to cover all buckets.
Of course,
Indian family.
I think the thing I was just so genuinely excited about, like, I think just watching their careers and like, what got them excited. A lot of it was about like, how do you actually make an impact with like the things that you do? Like when we're building a lot of these systems, a lot of it is actually focused on, like here's like the technological advancement and like, here's like the nugget of information or new discovery that we're making. That for me was incredibly exciting. And then also seeing how you translated it into things that people can use, right? So a lot of my time actually at Stanford when I was doing my PhD there, first few years we spent on like, basic science, right? Just like getting to the nugget of truth, like what are new ways that we can think about. My background's in like electrical engineering, signal processing. So how do you take those fundamental principles and use that to make machine learning more like data efficient, more hardware efficient, that kind of stuff.
Absolutely.
Got into medicine again there. And I was like, a lot of the problems that they run into deal with like, size of the data that you're trying to process, deal with like nuances around like who are the patients, right? Like how do you make these systems more bespoke and specialized? And I was like, these are just like problems that exist broadly in the world, right? So I found like a lot of passion and love doing that there. And I think when we were starting Cartesia and thinking about audio, like a lot of these properties just like popped up, right?
Like how did you go from like medical imaging and research, electrical engineering to voice? I feel like that's like a pretty big, leap. I mean, the research element is definitely pretty strong in both, but I'm kind of curious how you made that leap.
Yeah, I think the application for me was never it wasn't about like exactly where it was being applied. It was more about like the impact of the application. And how that connects deeply to the fundamental research concepts that really excite me. Right. A lot of the stuff that, I'm really thinking about is like, how do you think about models as like compressible signals? Right. Like, is there information in models that you can like, compress and like get it to fit on devices that are like, in your pocket, right? Or
Right.
you could like, you know, implant in your brain, right? Or something
Uh-huh.
like that. I think those are like really exciting research problems.
Yeah.
They connect very fundamentally to, whether that's in audio or in medicine, they just like connect to problems that are fundamental about signal processing.
Right.
And I think that's just like super cool, right? Like seeing like, signal processing has been around since like, God knows how long, but
Yeah.
a lot of these principles, the fact that they've stood the test of time and you get to like rediscover them kind of in these different applications, different
Yeah.
modes. I think that's really exciting.
Huh.
Medicine was never. I never ended up becoming the medical doctor. But I think it
Uh-huh.
was always like a great avenue to
You
discover.
failed all of your parents'
I
dreams.
did not. I think they were. It was. They were like, dude,
They're
just
pretty satisfied with the founder afterwards.
no. I think they were just like, do whatever you want, dude. They were just
Uh-huh.
like,
Okay.
you seem interested in things. I feel like
Right.
they're like that's important, and like you could figure out the rest
Yeah.
at some point. But I think like a large part of it for me was, I want to really work on these kinds of problems that have a direct impact on people's lives.
Right.
I want to be able to think about fundamental research through that lens,
Right.
and really make these fundamental advances, regardless of what the modality is, in a way that's like just,
Yeah.
you know, meaningful, I think,
Right.
to the world.
Makes sense. And for those who like may not know, I mean, like Cartesia at this point is like a pretty big brand. I feel like a lot of people know, but like
Yeah.
mainly, could you talk about like your main offerings in the market right now? I mean, I know you guys started out with text to speech, but you guys have now expanded beyond that as well.
Right. Yeah. So, I think the reason, I talked about like, how Cartesia we're trying to solve this problem of like
Yeah.
interactive, machine intelligence. The reason that we really started with voice, maybe to like give some color there, is that it's honestly just like conversation is the essence of interaction, right?
Yeah.
Like you can't think about interacting with the world
Uh-huh.
without interacting with different senses, and one of those
Right.
senses is like, listening and speech, right?
Right.
And so the areas that we found that people were really excited about and that we were really excited about from the research and an application perspective were around like generative voice
Okay.
and voice understanding. So like
Right.
voice understanding is a lot more about like, the traditional is the STT
Right.
product, right? Where you go from speech to text.
Yeah.
So we released a product, Ink Whisper.
Yeah.
So whisper-based model, which is like,
Yeah.
one of these large, pre-trained audio models that was
Right.
created by OpenAI. But really, we really focus on the idea of how do you make it like run incredibly fast, right? The whole
Right.
premise of interaction is that you want that low latency feeling where you
Right.
feel like you're interacting with someone.
Makes sense.
And so that was like kind of the speech to text product. And of course, you alluded to that, the text to speech Sonic,
Yeah.
one of our, flagship products that we have
Right.
been around for, over a year now.
Yeah.
And there, I think, a lot of the boundaries are pretty endless, right? Like
Right.
we thought very deeply about like, okay, what are the trade-offs that you typically have to make with these
Right.
systems for quality and latency? And we are like, we're not happy with the trade-offs, so why not just move the pre to frontier? And a lot of the research that we did during our PhDs, so myself as well as Kern and Albert, who were actually leading a lot of the research during their PhD on state-space models, was really inspired by this problem, right? That
Yeah.
generally there's this trade-off that you have between
Right.
quality and speed, and why? Why do we need to have it?
Yeah.
Right? Like, can't you
Yeah.
do both?
Both.
And of course, there will always be a trade-off, but like
Yeah.
there's different ways of formulating these systems
Right.
that is just like a lot more elegant,
Right.
right? I think if you, I'm sure if you talk to Albert, he'll appeal to the intuition of
Yeah.
a lot of like, these just seem like the right systems to build.
Right.
And I think like, a lot of it actually is inspired by signal processing. So being able to see that, at the fundamental research level is just
Right.
really, really cool. And so, yeah, I guess, not too much of an aside, but, we allowed us to build some of, the best foundation models.
No, it makes sense. And you guys have like a completely like different approach, as I've read from like the typical like transformer based architectures.
Yeah.
Can you elaborate more on that and like how you guys kind of think about it? I
Yeah.
think you alluded to it a little bit.
Yeah.
Yeah.
So, during our PhD, which is where all of the founders met, and Albert were actually working on, these kinds of problems on, sequence modeling, right? So
Right.
during the time when transformers, came about, like 2017, 2018,
Yeah.
there's this huge craze about like, you can model information as like sequences, and you can,
Right.
like, you can do it with much higher quality than, you could do in the past. I think what was really interesting was that like, these transformers, they fundamentally work kind of like a database,
Right.
right? So you keep a bunch of these tokens or this context around, and like anytime
Yeah.
you're generating what we call like, your next step or taking your next step, you're like looking at all of the tokens you generated or that
Right.
have been provided as context and seeing which ones are the most important.
Uh-huh.
But when we think about how people process information, I don't think we keep like a database in our head and then it's like, oh, here's a spreadsheet and I can just
Yeah.
look something up. A lot of it is about memory,
Yeah.
right? It's about like, trying to remember things that you think will be important and saying like, I'm gonna cache this, right? Or I'm
Right.
gonna like keep this around in some form that I can pull back later. And that's how a lot of these more recurrent models,
Right.
or newer recurrent models like state space models really behave, which is like there's this concept of memory, which is like a fixed, imagine like a fixed, amount of space that you have,
Mhm.
and you're figuring out like how to update that space to like keep information in it,
Right.
right? Compress it in particular ways so that you can like reconstruct or like pull from it later.
Right.
And the beauty of this on the computational side is because it's fixed memory, your memory doesn't, scale with the more tokens that you generate,
Right.
which is typically the issue with transformers. So transformers are not computationally efficient at these very long context lengths,
Right.
but these state space models are.
Uh-huh.
And when you think about applications like audio or like, long context videos and
Right.
images, things like these, it makes sense that like you don't want to keep every piece of context around, right?
Makes
You're
sense.
trying to just generate based on like, what information you have about like the global state as well as like, what you've just generated to figure out like what are the next things that come about. So
Right.
if I were to distill like kind of the message, right, I think about SSMs more as like um human memory,
Right.
transformers more as like these databases where you do lookup,
Gotcha.
which is what makes it hard for transformers to scale.
Interesting. Yeah, no, I think it's super cool to like I was reading a little bit about, your guys' approach and I
Yeah.
thought it was just really interesting because it was just I think drastically different than
Yeah.
like a lot of the other models that we see. And so I think it's super unique. And then
For sure.
obviously you guys have your like super fast latency and really cool models because of that. So
Yeah.
that's also great to see in practice.
Yeah.
You've kind of alluded to like more than just audio. Like I think like the moment you started talking about Cartesia,
Yeah.
you alluded to it as beyond just audio. I
Right.
think from my perspective, as having used your models, every day we use it in BlueJ.
Yeah.
Like from my perspective, it's like we see it as like a very audio native company, but maybe that's not the case. So I'm kind of curious, like what other modalities do you guys see as really interesting
Yeah.
that you may potentially enter into the future?
Yeah. I don't even know if it's thinking about like entering into that
Uh-huh.
particular modality. I think it's more just like where do I think the field should go?
Okay.
Right. I mean, I think, videos are awesome, right? There's a
Right.
lot of great companies that are working on videos, right? Whether that's like, generative landscape videos, like
Right.
real-time avatars, right?
Yeah.
And I think it's just being able to see that like people are very interested in this like interactive flow
Hmm.
of these different like how you can make a lot of these modalities more interactive. I think that's like kind of what we're very excited about.
Yeah.
The place where I think, folks are not like thinking about as much right now is like, what's the point of like what are the goals of this interaction, right?
Right.
And what are the things that actually make interactive systems like good?
Yeah.
I think for me there's really three properties, and this spans across any modality that we actually think about, right? Like
Right.
there's quality. So
Yeah.
you're thinking about, let's say naturalness of your voice and like
Yeah.
accuracy, right? We know like sometimes models hallucinate.
Yeah.
It's a big problem,
Yeah.
right? How do you like drive that down?
Right.
The second thing, which of course is a nuance of interaction, is latency.
Yeah.
So I think typically when people think about efficiency in these models, a lot of it is about throughput, right? Which is like,
Yeah.
how many tokens can I process per second?
Yeah.
But actually with interaction, you're thinking about something a lot more specific, which is like, how do I get the first byte of information back to the user
Yeah.
as quickly as possible?
Yeah.
And in audio, this matters a lot,
Yeah.
right? In video, this also matters a lot,
Yeah.
right? If you were thinking about digital avatar, those kinds of interactive platforms.
Right.
And how do you do that when the amount of information that you're supposed to generate is so large?
Right. And it's like real time, you're generating it all the time. Context is changing. Yeah. No, it
Exactly.
makes sense.
Yeah. And then the third, of course, is controllability. So,
Yeah.
um, you know,
It's probably the toughest, one of the tougher ones. Yeah.
it is tough,
Yeah.
but I think like for adoption,
Uh-huh.
especially when you're thinking about interaction, it matters quite a bit,
Yeah.
right? Like not being able to have a system be customized to you, like
Yeah.
would I want to use a system like that? I don't know. Maybe I'll use it for like some generic things that I think it's pretty good at, but I may not use it for like, to be my assistant, right? Or
Right.
like, you know, do the things that I would want to do on like a personal level.
Right.
Yeah. So I think, you'll see some of this with Sonic 3. which I guess, you know,
You've heard about it now.
Yeah,
Now I'm releasing this on Sunday.
Yeah. Don't make my marketing team kill me. Yeah, I mean, I think it'll be pretty
Sorry,
exciting.
I clicked the post button too early. My bad.
As long as it's
It was
12
an
a.m. on 12 a.m. on Monday, I'm sure we can work something out.
Yeah, that's super. Anything you can. I mean, obviously this will come out after that.
Yeah,
Anything you can tell us about the model, like
Yes.
what people can expect.
Yeah. Sonic 3 is the fastest, most controllable text-to-speech model on the market.
Okay.
It's the first model that allows you to
bold statements.
It is a bold statement. It is a bold statement. I'm biased.
Yeah,
it is a bold statement.
Okay. Yeah. Continue.
I think one of the big things, right, is like people want control in these streaming settings.
Yeah.
Right. So, you know, just going back to like this whole interaction thing, the way you get low latency is you stream your apps back. And I think for me, actually being able to see this model allow you to do things like control emotion on the fly. Yeah. Is super exciting.
Yeah.
You know, imagine like I'm having a conversation, right? You know, I might say something right now, super excited and elated, but if someone responds to me in a particular way, I want to switch that emotion like
absolutely
urgently, right? And so, and then when you're in a voice agent, you need to make sure that these are like, you know, super fast responses. And so, you know, you can do that with Sonic 3. So I think to the best of my knowledge, it's also like the first model where you can like control emotion like on the fly. Okay. Like in like very low latency interactive setting.
That's super cool. Yeah. That's super cool. What's anything changed behind like the technical framework around how you guys built and trained this model, or like talk us through the process a little bit if you can.
Yeah. So I mean, I think a lot of, you know, when you think about modeling, it comes down to two things, right? What is a model made of? It's made of the data. Right. It's made of the architecture. Yeah. And you know what we're doing is like you're also building these systems that, you know, allow you to process, you know, data more efficiently, allow you to train these models more efficiently. Right. Trying to really understand like where is that architecture and data like fitting well. Right. I think we actually like that's been a large part of like the modeling process. Right. Right. And it's something I think, you know, we definitely got much better at in Sonic 3. And I think, you know,
how are you benchmarking these things, right? Because like for example, like you're saying right now, right? Like Sonic 3 is going to be like super expressive and like all of these emotions, but like that's a very like qualitative, like
100%.
Yeah, like
100%.
Like I'm curious, like how do you guys like? I mean, we see the same thing at Blue Jay, right? It's like, hey, how do you understand whether something is actually emotionally better than the previous one?
That's right.
Because I mean, it's very vibe based to an extent, right? Like I'm curious, like how are you guys doing that?
Yeah, evaluations are hard. Yeah, I mean, there's no shortcut here. You know, of course, there's a lot of these new methods around like LM as a judge and you know, creating heuristics-based metrics for like measuring emotion. You know, there's things that you can of course measure. Right? Speed, for sure, very easy to measure. Right? It's like very quantitative. But a lot of these qualitative things, I think there's been two approaches. One is try to find the best, you know, amalgam of heuristics that allow you to like approximate that. Yeah. The issue is that's very hard.
Yeah. Do you guys do like focus groups, or like do you guys have people come in, listen to it, understand it? Or
I mean, a lot of it is actually human evals.
Human evals,
yeah. I mean, like, you know, you guys know this space incredibly well, right? It's like you need to have, you know, there is some level of like vibes-based checking, right? Of making sure that these models are performing in the way that you expect them to. Right. The question is, how do you actually do that at scale? Right. Because if you're thinking about like, my background is very much on like, you know, I've done a lot of research on like, you know, evaluations and like what are good ways of posing these for a lot of applied problems. And at the end of the day, people are like, oh, cool. It's just like, this is the mean of what you get. Right. But what's the variance? What is the likelihood that I'll have consistency? How can I be sure that when this is the prompt that I give it, that these are the results that will come out? Yeah. That's hard. You guys seem to have doing that pretty well.
That's kind of what we're aiming to solve. Yeah. And hopefully providing that to our customers. But I think like it's interesting because I think with like TTS models specifically, the challenge is like, you know, like you go ask like Bob in Idaho, like how a voice sounds. And then you go ask like, you know, Rohan in San Francisco, how a voice sounds. Yeah. And Rohan and Bob are going to say like completely different things about the voice.
For sure.
And so that's kind of like the interesting part behind like some of these things like emotion and tone that I'm always interested to understanding. Yeah. Is like, how do you guys as the model builders, account for that?
Yeah.
And this also matters a lot, right? Because now if you take these models into like enterprise, systems and
Yep.
like, I don't know, like fast food chains or like, people who like care a lot about the tone of voice and like their customers and like how it sounds and
For
stuff
sure.
like that.
Yeah.
I'm kind of curious, like, how do you build a general model that accounts for that? Like, what are some of the, maybe it is you just have like people coming in constantly listening to it and saying, hey, I like this. And then that's kind of feeding in some sort of, general eval approach.
Yeah.
That's, more scalable, as you said,
Right.
but would love to understand like any things you guys did.
Yeah. I mean, I think, you summarized it well. Like the reason that controllability matters a lot, actually high level, is there's a brand, right?
Exactly.
When you're selling to enterprises or like, any customer really, right?
Right.
There's a brand that you want to exude. There's like a personality that you want,
Yeah.
especially in these like generative voice applications. So the way I think about these systems is, you know, not like, can we pick all of the voices that everyone will want to use like in the market, but actually more from like, how do you build a general system from first principles
Right.
that gives users a level of control and flexibility.
Yeah.
And like some amount of stability
Right.
to be confident that these are kind of what the results will sound like.
Right.
And when you do that, now it's not like a fixed space that someone has to explore and you test against, which, of course is very beneficial for things like evals.
Right.
But it gives people the freedom to say like, hey, these are the pockets of like, controls that I care about.
Right.
And this is how I'm going to be able to like do customization. This is actually something that was very fundamental to when we were building Sonic. And, Sonic 2 was, the first, breakthrough here, which was giving people like the ability to like perfectly clone
a voice.
Yeah.
No, it's really cool.
Because like, I go to Aston Martin, the voice they're going to want to use, the language, the pronunciation, all of these things that they're going to want to do is going to be completely different than if I were like, at Ford and trying to sell a car, right? Clientele is very different. The brand is incredibly different.
Yeah.
So why not just build a model from first principles that allows you to get this coverage? And now you're not just evaluating the coverage, you're evaluating something much harder, which is like, is my model like generalizable enough to do this?
Yeah.
Yeah.
And I assume, do you like, how closely do you guys get to work with like some of these end brands? Because I assume like you're normally probably getting deployed in a voice agent builder who's then going to some of these brands, or do you guys also get to interact, sometimes directly with like Aston Martin's, Fords of the world, so to speak? And if you do, like, what does that collaboration look like in terms of, do you guys do anything special to kind of really get the voice sounding the exact way? Or is it kind of what's available to the public right now where I can go in and, upload my files, train it, clone it, and so on?
Yeah. So it really depends, right?
Yeah.
I mean, I think the beautiful thing about like a model platform is that, there could be teams who are building voice agents who are selling to these end customers. The end customers who are like interested in spinning up internal teams to build voice agents. So we kind of get a mix, right? Like, we get to work with these brands, but we also get to like, work with the people building for these brands.
Yeah.
And I think just like generally from like a pollination of ideas, I think it's just very, very great, right? I mean, I think that's something I really enjoy about, the way the platform has evolved. Now, how we build voices, it's more about like, it's honestly like, you're teaching people how to use a system,
Right.
but you don't want to like teach them to do things in a very finicky way, right? You're trying to build a system that's like intuitive, right? It's like ergonomic for the way that developers build.
Yeah.
I think we've really spent a lot of time thinking about that. And hopefully, people see that like, this is the way that I would like interact with these kinds of systems moving forward. But yeah, I mean, we are happy to like, talk with customers and say like, hey, here's some voices that have had success in the past. Like, maybe this will kind of fit your use case, right? Or, maybe they're like, hey, this is a voice that I really want, but I wanted to like, sound sadder, right? How do I control that? And it's like, oh, we have knobs for you to turn, right? In order to get the level of like, to get that granular control that you need.
Makes sense.
To get the experience that you want.
Right. And over time, have you seen like more non-technical people like adopt Cartesia? Because like I feel like that's like the wave we're seeing in AI. I mean, even with our product, we have a range of like people using it, ranging from like your engineers to like PMs to even like salespeople. I'm kind of wondering if like you see the same trend happening with your product and how that's impacted how you guys build these systems.
Yeah. So I think we're very developer centric.
Okay.
That doesn't mean that people can't build without code, right, on our platform. So, we recently also introduced a new platform called Line, which is our voice agents
Absolutely.
platform.
Yeah, yeah.
The principle behind Line is still very developer centric, right?
Right.
It's like, we fundamentally believe that in order to build these complex agents,
Yeah.
we're going to have to work to some extent in code,
Okay.
right? And there needs to be some level of like, customization and
Right.
nuance that is, typically driven by code
Right.
and hard to expose from like a
Yeah.
pure no code, setting.
Right.
That doesn't mean that you can't like initialize an agent with like prompting, right? Like if you think
Right.
about like, you know, like the lovable style approach, right? Which is like, hey, look,
Yeah.
I'm gonna like type in a prompt and like have it build.
Because Line incorporates some of that
It does.
style, right?
Yeah,
And
yeah.
it does, which is interesting because it does take away a little bit from the development effort at the same time.
Yeah.
Is that fair to
I think
assume?
it provides a different avenue for
Okay.
people to get started, is the
Yeah.
way that I'd describe it.
Okay.
But as a developer,
Right.
you're not gonna take that at face value, right? Just
Right.
like, well, I mean, I hope like, when you have like Cursor or Claude, like code for you,
Yeah.
there's at least a little bit of like supervision around like, okay, well, is this actually doing what I want or not?
Yeah.
Yeah, maybe that's a tall ask, but
Yeah.
I do think like, that's kind of how we imagine that experience. And at the end of the day, right,
Yeah.
like it's about giving people the different, modes of interacting with their code
Absolutely.
that allows them to build these complex agents in
Gotcha.
a way that's like versatile and really bespoke to what they're trying to do.
So you guys are like fully set, hey, the no code builder option, that's not really what we're excited about.
Right.
We want to live inside code.
That's right.
Okay.
That's right.
Awesome. Yeah, no. I saw the Line launch and I thought it was super cool.
I
So
appreciate
yeah,
it.
no,
Yeah,
congrats
yeah.
on the launch.
Thank you.
How's that been going for you guys? Because that's like dramatically different from like the areas you've been interacting with so far, right?
Definitely, yeah.
Yeah.
I mean, I think of it actually as like, an expansion of the platform,
Yeah.
right? Like, there's people that want to like consume TTS and there's people
Right.
that want to consume STT, and that's great, right?
Yeah.
We have a playground, there's ways of doing this in like a no code way too.
Yeah.
But when you're trying to like deliver the end-to-end experience, like it's clear that like voice agents are,
Right.
the large head of like where voice AI is heading, right?
Right.
And so I think for me, it's about like how do you actually give people different, levels on the platform that they want to
Right.
build on, actually allow them to like use a lot of the pieces in
Right.
like a centralized way.
Yeah.
But also like, integrate well, right, with like, their flows. The beautiful thing about code is like it's often very portable. So for us, it's not like, you have to like come to Cartesia and like, use like, you have to like, build online if you're trying to use our TTS and SCT products, but it's like, this is a platform, you have code.
Right.
There's things that we can do for you, like, like co-location, which actually like, improves like general networking speed and things like
Yeah.
that. That, is a large part of like, the experience and deliver like, the end-to-end system that, you're interested in. Right. And
Absolutely.
I think because Line is very code first, it really is about like meeting people where they are, right? A lot of these digital native companies, even enterprises have built like great chat solutions.
Yeah.
Why should I ask them to like rip that entire thing apart and make it very difficult for them to add voice?
Right.
Sometimes they just want to take the code and, stack the STT and the TTS on the other ends and say like, here, I have a voice agent, right? Like,
do you think it's that easy in practice?
I think it should be, right?
It should be.
Yeah. I mean, like, I actually think that is a important North Star.
Of course. Yeah.
Of course, it's not that easy because I think the nuances of voice are incredibly important to control.
Right.
Because it's just like there's like a whole different axes of like capabilities and metrics that you need to track, right? Like, you don't care about intonation when you're reading a chat message.
Right.
Clearly, you care about that when you're listening to a voice agent.
Right.
But again, this is where evals come in, right? And so I think, I mean, I do think it's like very interesting how you guys are thinking about this problem, right? Because all the way from things like, simulations to like actually being able for people to like, double click on like certain parts of like being like, oh, we failed here.
Right.
Like what were the failure criteria, right?
Right.
How are you guys really thinking about that? Because, I guess maybe I'll put the question back to you is how do you measure like the voice characteristics that are hard to measure from like the traditional reasoning side?
Yeah. No, I think, it's a great question. I think we're always thinking about, hey, how can we get better at it?
Yeah.
But the way we look at evals when it comes to, voice agents in particular is that it kind of ranges across a few different buckets, right? So one is like, before we even go into like conversational quality as a bucket, just thinking about functional performance is like, hey, like, are the right tools being called? Right. For any agent that's taking a lot of actions, that's like one of the first things that we want to test for and engage for. Right. We really want to understand, like, hey, are your functionalities being called the way they are supposed to be? And this matters a lot in really like sensitive industries like healthcare, for example. Because if you have a patient, they come, they say, hey, I want to book the appointment. The underlying tool call fails, but verbally, the agent says, hey, the appointment's booked, you're screwed, right? Like that is not a great, system to be in. So that's like kind of the first part that we will, really tell our customers like, hey, like, let's first make sure we get the functional characteristics down, even if that means sometimes compromising on the quality, right? That way, at least it works end to end. The second thing that, we really start to think about is from the conversational quality side of things, which then gets into, sort of like voice evals, right? Which is like, okay, there's some evals which you can run directly on the transcript and other contexts that you may have about the conversation, like your tool calls again. But then there's some evals that are very voice based. So for example, we'll try to pick up on interruptions. So we try to say, okay, if there's interruptions on this call, when did it happen? How did it happen? Let's mark that to the user. Obviously, there's things like latency, as you mentioned. We can easily track that. That's very deterministic. And tell people, okay, this is how quick your AI was at responding. And, hey, like, let's try and get that down and try to advise them and stuff like that. So then there's the trickier things. And so we've tried to do this with like a pronunciation eval, which we've tried to build, which technically analyzes the underlying TTS model that you're using. And so we try to say, okay, for like common words, is your agent mispronouncing things? Right. So, saying things incorrectly. And this matters a lot for some of our customers when they're like saying like big brand names.
100%.
Like you can't be mispronouncing a big brand name if you own the brand. Right. And so that becomes like a really interesting eval, trying to look at audio directly and check for artifacting and stuff like that. So that's another thing that we're really interested in and we try to implement as well within our systems. That being said, at the same time, it becomes more interesting because these are all like standard evals. A lot of the times customers will, like, we're a horizontal platform like you guys, right? And so like the challenge that comes with that is like, you go and deploy this thing and a healthcare customer has a very different type of eval that they want to run than a finance customer.
That's right.
Right. And how do you build a generalist platform that can accommodate all of that without essentially writing new evals every time? Right. And so that's kind of like the biggest challenge, which we've attempted to solve. And, we obviously use, characteristics like LLM as a judge and stuff like that. And try to do audio native evaluations as well to pick up on things like emotion and sentiment. And so those, tend to help a lot. But that's kind of like the way we think about it is like bucketed, right? You have function, conversational quality. And for some of our like larger customers, right, starting to think about scale and issues that come with that as well. But that's like kind of roughly how we try to think about it. And then ideally try to fix it for them too. That's like the next step. But but you guys, the reason I like Line is because I feel like you have created this very circular loop, which can hopefully improve over time. Is that like the goal there?
Yeah, I mean, I think there's definitely a world where you want the platform to be like not like here, go serve your model and like just let it be static, right? A lot of it is about like, is this platform actually helping your business like grow? Right. That can be whether it's like scale, right? Being able to manage that. That can be like, these like, self-improving loops where, these models can potentially, get better, right? The more they get used. I think like a lot of it is actually just like, I think again, when you're building like a product like Line or like a platform, right? You want to make sure that it's actually something customers will truly see an increase in ROI as they keep growing on the platform. It's not just like, here's voice agents for like 1.0.
This is
you wanna go down? This is like the beach if you want to go down there.
Let's go down.
Yeah. I think it's like pretty nice. It's a nice view.
I normally ride to here for the view.
I mean, Vancouver Beach is like, it's a really nice spot. So, this is a treat, man. You got a nice.
Yeah, we gotta pull you away from the office. Stressing about the launch.
No, it's. I think it's been great. I mean, honestly, like, I don't think I've worked with the team as like, not just cracked, but as like excited and like, just so like ingrained in like what they're doing is like, the folks at Cartesia, and like it's just honestly such a such a privilege and pleasure to be able to work with them.
That's awesome. That's awesome. And you met all of your co-founders like in the same like while you're doing your PhD at Stanford?
Yeah.
Or like were they in other places as well?
No, yeah. So all of us met during the PhD.
Okay.
We all were in the same lab actually.
Yeah.
Working on.
Did you guys start out as friends first, or like how did that happen?
Yeah, definitely. Yeah.
Yeah.
So yeah, I mean, Albert, Curran, Brandon, and I, I guess, Brandon was joined a little bit later in the lab, but we're all part of Chris Ray's lab at Stanford, and yeah, we're all just like kind of hanging and like all good friends, and I think what's really exciting when you're starting a company too is you want to make sure you have like folks that you can lean on and trust, and you're there's no like formality of like how transparent do you need to be, and like or anything like that. It's just like people know what each person is good at. You have like a good sense of like what everyone means, and everyone is in it because they're just trying to like get the best for each other and the best for the company, right? And so I think that was like a huge part of like why I was also really excited about starting it with.
Did you always want to start a company, like, or was this like kind of accidental?
I don't think it was accidental. I think for me, a large part of it was about again, like, how do you like meet people where they are and like actually deliver tools to them that are valuable for them to use. I actually was at some point interested in academia. I think the incentives there weren't necessarily aligned with that, at least in the short term. I mean, of course,
like monetarily, or
no, not monetarily, like just from like I don't think you get tenure because you deployed like a new algorithm at a hospital that is able to triage patients better. I don't think that's a bad thing, right? I think academia is like a very unique place where you can think about things at like a much deeper level, and you're working on like a lot of these fundamental problems. I think for me it was like I want to work on those problems, and I want to see like kind of what the
So you're saying I'm never going to see Professor Desai in action?
I don't know. Not in the short term. Maybe at some point. The thing I really loved about academia, and I continue to actually love about what I do at Cartesia, is like a lot of it is like working with people, a lot of like collaboration, a lot of synergy, and then also like to some degree like mentorship, right? So or to a large degree of mentorship. Like for me, it's I don't know everything in the world, so I'm continuously learning a lot more, like learning from people who've been in spaces that I haven't had the exposure to, and also I'm trying to pass along things that I think I could be helpful at, right? And, I think that's just generally I just enjoy that, right? And I think there's a lot of fun being able to do that with folks that you want to see get better.
You have like the best like answers, like
No,
like
I mean, it's I think these are things I've thought a lot about.
Oh no, it makes sense. They're good answers.
But yeah, I mean, it is really fun. I think there's like a whole other side of like starting a company, and I'm sure you know.
Did you grow up here in the Bay?
Yeah, I grew up. Actually, grew up in Fremont, and then parents moved to South Bay. Yeah,
awesome. Where I lived in Fremont.
Oh, really?
For a while.
Oh,
yeah. I mean, like I have a lot of family.
Yeah.
So that's awesome.
Where in Fremont you grew up?
So I didn't grow up. It was funny. I like was born in Southern California, and then I moved to Fremont. And I actually moved to India for 5 years.
Oh, okay.
And then I came back, but I was in Fremont for like a short amount of time. Yeah. Before moving, I went to like Challenger. I don't know.
Ardenwood?
I don't remember the
like in Newark or something.
I have no. Like Challenger School.
Yeah, Challenger School. Like in Newark. Newark's the city, right?
I could not. No, the one in isn't there one in Fremont?
There is one in Fremont, but it's like officially in Newark.
Oh, okay.
I also went to Challenger.
Oh, really?
In Fremont. Okay. So yeah, maybe we were actually at the same school.
That's awesome. Yeah. No, I was there for like half of like first grade before I moved to India.
Okay.
And like kindergarten. So like I was like,
all right. So
really remember, very short. Yeah, but like my for example, like my cousin like went to Challenger, and then he like went to like he did the Harker. I don't know where you went to high school.
I did not go to Harker.
Okay. But I would have guessed Harker.
Yeah, there are a few people that have gone to Harker at the company.
No, I'm not surprised at all. I feel like it's very popular.
It is. Yeah.
That's cool.
That's awesome, man.
Yeah.
We're in SoCal.
I was born in like Ventura, Ohio.
Okay.
But also like very young.
Yeah. So we spent 2-3 years in Glendale, like Pasadena, Glendale area.
Okay. Gotcha.
When I was growing up. So,
cool.
Yeah.
That's awesome.
Yeah.
Okay. Left field question out of nowhere. Speech to speed.
Yeah.
How do you feel about it?
I think it's exciting, man.
Yeah.
Like I think the essence of like what these systems can do when you're end to end is just like there's just some level of elegance to it, you know? I think there's a reason why it hasn't been adopted. I think the whole claim around latency, although I do think like, you can get there where like, these systems are much more efficient, right? From a latency perspective.
Right.
It's just not there yet. Right. Like a lot of the systems.
Do you think it will get there?
I think it'll get there.
Yeah. Do you think it's going to be like in the future where like in terms of like how people build these, right now it's obviously like these very like bifurcated systems where you have like 3 different elements playing around.
Yeah.
Do you think it's going to be speech to speech predominantly?
I think over time, yes.
Yeah.
I think there's a reason why these systems have not succeeded. I think latency was actually one part, but it's not actually the main one.
Right.
And the main thing is actually going back to the whole idea of like, controllability.
Yeah.
Which is like when you have an end-to-end system just like doing things,
right,
you're not able to intercept it in the same way that you can
Makes sense.
like, with the orchestrated system.
Right.
This causes a whole bunch of problems, right? Like any guardrails that you have or things like that are like very tricky, right, for you to be able to implement. And so I think there's like the level of control and nuance that you need for a lot of these voice agent systems at like enterprise grade scale.
Yeah.
I think speech to speech systems are not there yet.
Okay.
But I do think like, there's a lot of like exciting work that, I think will push us.
Do you guys think you'll like get into the space of a speech to speech model?
I think it's definitely very exciting, right? I mean, it's, very natural next step for like, voice companies. I think for us, it's less about like
some difficult questions.
Yeah.
I mean, turn around.
I'll answer to the best of my ability. I do think like when we're building some of these systems and not not just like speech to speech, but like any of these like end-to-end systems, it's really about thinking about it from first principles, right? Actually, that's a huge part of how we build at Cartesia.
Right.
It's not just that like, did customers X, Y, and Z complain about this? It's about like, yes, that's important. And like, we need to actually understand why they're complaining about it.
Right.
To be able to understand from first principles,
So
like
how to
patch it, right?
Right.
And, I think like there's this really nice, like, I forgot who drew this diagram, but they're like, there's patches you can make at the engineering layer. And then there's like things that like trickle down into the model.
Right.
I think for us, it's very much about like, why do we have to make patches at the engineering layer? Like if we do, that's great. We'll do it, to solve some of these short-term problems. But we really, really do want like, fundamentally we really do want fundamentally to like make a lot of these systems super like first principles based, right? It's like, this is how we think the world should look.
Yeah.
This is how we think people should interact with these systems, influenced by how people are interacting with it now, how people will interact it with in the future. And like, let's put that into the model.
Okay.
Yeah. I don't know if that made sense, but that's kind of just like a philosophical take.
I want to understand a little. I want to try to get like in the weeds there a little bit. Like, what does that first principle take look like? And then I've spoken with a few engineers at Cartesia, and I think like an interesting argument that, can potentially also be made is where if you have like a really good model, then even if your SDT like makes like some issues or like screws up, if you can still capture the like main intent,
right,
you can still like course correct, so to speak.
That's right.
But I'm kind of curious, like in general, like what does that first principle perspective look like in terms of these models, like specifically?
I think so. I think if you were to like go back, it's like those 3 pillars, right? There's quality, there's speed, and there's controllability. Now within that, there's a bunch of things that you can explore. So with Sonic 3, a large part about it is like this controllability. It's like you can pass in these like SSML like emotion tags.
We use those.
Yeah.
We use them to, I don't know if I told you, we have a customer who's like a language tutoring company, and we like manipulated it to like kind of do the opposite of what a TTS is supposed to do.
Okay.
So like instead of like having like really good speech and perfect clarity, we would manipulate the words using SML tags to like fuck up the pronunciation, intentionally. So we use the tags to do that. Which is maybe your intended use case, but
But the fact that you can do it is actually not because like we're like, oh, people want to use SSML tags in this way only, and this is what we'll support.
Right.
It's about like, okay, people clearly want this level of control.
Right.
How do you bake that into the
model? Yeah.
So that's kind of like, again, first principles it's a very like opaque term. I think.
No, but I see what you're getting at. It's like, hey, like I'm not going to I'm going to provide you all the tools that way you can do whatever you want to do.
Right.
But I'm not necessarily going to create the house for you. Like you can create the house however you want.
Yeah.
Using our tools that we provide to you.
Yeah.
It's interesting though, because you've somewhat also now created the house with line.
It's true. That's true. Or we've given the wood panels, right? Like
okay.
You can still assemble it however. But I think that's actually a symptom of building from first principles. Like when building from first principles, a lot of it is about like fundamentally,
Yeah.
how do you like not just how would someone want to use a system like this, but like what does it mean for a system to have these capabilities, or for a
Right.
model to have these capabilities? And I think the being excited by that question makes you just generally excited about like the downstream, which is like,
Right.
okay, how will people use this, right?
Yeah.
And then getting to see, folks like yourself, like just use it in ways that, we didn't even expect.
Yeah.
That's just like, it's just awesome, right? I mean,
Yeah.
like it just like, it feels so much cooler to say like, look, I built this like general system,
Yeah.
right? Or general model that people are able to like customize in the way that they feel best.
Yeah. And use it for whatever, they need to do at the end
Exactly.
of the day.
Yeah.
No, I think that makes a lot of sense.
Yeah.
Yeah. No, it's super cool.
Yeah.
Are you guys also going to do chat? Do you think?
Like text to text kind of models, or
Like you have like a voice agent? I don't know about like, I mean, all of our customers, like for us, like for example, we released a chat-based simulation tool as well, and observability for that as well.
yes.
And it was not because like we set out to do that from day one.
Yeah.
It was more just like every voice builder we met was also building the chat version of that.
Yeah.
And so I'm kind of curious, does Line also expand into that as a modality?
Yeah. I think we actually do have something on our CLI.
Okay. So you already do.
Yeah, that allows you to have like open up like a chat interface with like any of your agents.
Yeah.
And just like chat with it, right?
Okay.
And again, fully streaming, like, you
Okay.
get tokens
Awesome.
back streaming. And so I think like it gives you like the semblance of speed. But I think
Right.
to your point, when you're thinking about like evals along the lines of like, is this functionally correct? Right? Is
Right.
this doing what I wanted to?
Yeah.
That's like a great way to like do some of that litmus testing.
Gotcha. Or I guess the question I'm more asking is like, do you guys like see like an omni-channel line agent your customers use, right?
I see.
So like, are they gonna, or is it gonna be primarily only voice agent?
No. I mean, I think like when you think about information, right, it's just information can be anything,
Right.
It can be
Yeah.
audio, it can be like dial tone inputs,
Right.
it can be like, other text inputs and stuff. And so,
Yeah.
I mean, I think like a good voice agent platform, and you can actually do this in line also,
Mhm.
like, allows people to like, send the information that they feel is relevant,
Yeah.
and then have their reasoning code, right?
Yeah.
Operate over that however they see fit.
Makes sense. Makes sense. What challenges have you seen after launching Line specifically that, developers have been coming to you with in terms of like, building these voice agents more reliably?
Yeah. I think it's actually quite interesting. It's not as much about like what the challenges are. I think it's a lot of it is actually about like how do you like get get the level of like customization
Uh-huh.
that a lot of these builders often want. So uh I think what we found is that and this is again the premise behind Line is people always want to just like dive into the code if they're a developer, right? I mean, if
Right.
you're not a developer, totally makes sense, right? That's not kind of the bread and butter of like how you build, but
Right.
I think a lot of people are just like, look, I need to like decompose this agent, and you need
Right. And you need fine grained control. Yeah. That makes sense.
yeah. Tell me like what this API does, and like what event you're sending me, and how I should process this properly. And I'm like, we can give you the scaffolding. In fact, I can like give you like a templated house, right? If we're using that analogy, and you can go ahead and use that.
Right.
But you can also customize the sync, and you can, you don't have to buy it as is, right? Like you get this flexibility of being able to like tinker with things,
Right.
that you may not have gotten before. I think like actually when a lot of these builders like, end up building, right? I mean, there's tons of voice agent like builder companies out there, and
Mhm.
and many of them are platform companies, and it's really exciting to see kind of how people are using a lot of these tools.
Yeah.
For things like, demos and experimentation, and like what goes into production, and how
Right.
they actually like do their evaluation and analytics. And
Right.
I think that ecosystem generally is like, Line can provide like part of it, right?
Right.
And I think that's, in a part of it in like a very customizable and a flexible way, that I think, a lot of developers have found quite useful.
Makes sense. Makes sense. Yeah. And are you seeing like I'm always like wanting to learn like how many of these things are actually making it to production and handling more than just like 10% of call volume or like this like subset of call volume? Have you been able to see like larger adoption, of like Line powering some pretty cool, like large scale, like voice AI applications?
Yeah. There have been a few. But I think even like broadly, like we're thinking about like voice AI platforms, I think that's like a very open question, right? Which is like, am I gonna ask like, I mean, I guess like you can remove this if you can't save. Like, am I going to ask like a Sutter Health to like switch all of its patient scheduling to like 100% on AI,
Right.
on like voice AI
Yeah.
platforms? I think for us, they're not a customer or anything of ours, but I'm just using them as an example.
Right.
A lot of it is about like how do you accelerate
Right.
that.
Yeah.
That acceleration has to do with developer ergonomics.
Yeah.
That has to do with the level of customization that they can do in like short amounts of time.
Mhm.
And it's about being able to run these things at scale.
Yeah.
I'm sure you see this too. Like,
Yeah.
unless, especially like, finance, healthcare companies, like,
Yeah.
unless they see that there's low variance and statistical
Yeah.
significance that like, this works,
Yeah.
they're not going to put it in production.
Yeah.
Right.
No, they're just not.
Yeah.
Yeah. And it's like, I mean, what we've seen is we've seen like a hybrid approach
Yeah.
for like a lot of these deployments that
That's
go
right.
into production, which is like you're still using some of the more deterministic flows from like the previous like IVR age.
Yeah.
And you're mixing it with, you know, sometimes like some of these LLMs and like kind of like different, like if you think of like a state-based machine and like a
Yeah.
workflow-based agent,
Yeah.
you kind of mix these in like different parts of the workflow.
Right.
That way you have like a lot of these enterprises can then get really granular control over like, hey, like I only want this specific part to
Yeah.
essentially have AI turned on.
That's right.
Otherwise
Yeah.
it's going to turn off.
That's right.
And that's what we've at least seen right now.
Yeah.
But I'm curious if you guys are seeing like a different push. I think more and more people are like, I was on a call this morning actually.
Yeah.
And with like someone we're hopefully trying to sign.
That's great. Yeah.
But they were essentially saying, hey, we like keep pushing more, like we keep getting pushed by our customers to go more and more agentic.
Yeah.
And, now it's gotten to the point where it's either hybrid or agentic.
Yeah.
It's not deterministic anymore, at least according to them.
Yeah.
And so like my, next question is like, have people just stopped that in conversation, or is there still some push in that direction?
Like more on the deterministic?
Yeah. Is there like push against the deterministic flow completely and more into this like agentic based approach now?
Question. I think there are still deterministic flows, but
Yeah. Oh no, there 100% are.
Yeah,
Yeah.
yeah.
Those are like active and empowering.
Right.
I'm just kind of curious when people are thinking about like net new systems to build,
I see.
are they essentially like now confident enough that, hey, I either want to do hybrid or full AI? And I've kind of realized that the ROI behind, switching to these is just too great
Yeah.
for me to even consider deterministic flows, if that makes sense. Like
I
some of
see.
the old, like, I don't know, like IVR, whatever systems
sure.
that people build with, if
Yeah.
that makes sense.
Yeah. I mean, I think there's like, I guess in foundation model world, these are called like the emergent capabilities of kind of just letting it, letting the system like behave as it would, right?
Uh-huh.
Like seeing how it behaves.
Right.
I think the tricky thing here is that I think hybrid is kind of what I expect these systems to look like.
Right.
But I do think people are curious about what like the
Full
agentic, and like I just like, turn it on and then just like kind of see it unfold, what those systems look
What
like.
do you think needs to be done for us to get there?
I think the models need to be more capable.
Okay.
I think they need to be steerable in a way that they aren't.
And like, what does that look like, right? Because like right now we see teams just like invest a shit ton of time into prompt engineering to do that.
Yeah.
I've seen some teams with like 14-page prompts, which is like crazy, right? Like
That's pretty insane.
yeah. Having like that long of a prompt is obviously means that, hey, it's not super steerable, as you're saying.
Yeah.
So like, how do we get to that stage?
I think prompting is not the only way.
Okay.
I guess prompting, prompting is like a very, umbrella term, right?
Right.
Text only prompting is not the only way of getting these systems to like behave in the way that you want, right?
Okay.
I actually think a lot of it is about the interaction with these systems, or coming back to it, which is like, if you feel like the conversation isn't going in the way that you expect it to, like let it evolve, let the agent do what it's supposed to do. But if it's not, you should be able to like intervene, and like those intervening or interception messages should be sparse.
Okay.
Right? They shouldn't be like, I create a prompt and then like I have to like customize it like super detailed at the start. It's more like I have some, smaller prompt or some initialization of the agent.
Yeah.
And remember, a prompt is for a single LM, right? But when you think about the reasoning layer, it's about, there's like so many different pieces here that are put together. But then how do I like just, guide it in the right way? And then what does that guidance model look like?
Right.
Right. Like what is there like a, people call it like the chat supervisor paradigm.
I was just about to say like a supervisor looking at.
Yeah.
Interesting.
And so I think that's how I feel like a lot of this like hybrid approach will kind of evolve. But
I think of it kind of like a parent watching their kid.
A
Like,
little bit.
yeah,
I mean, I think the interesting here is like if the parent, like when a parent watches a kid, hopefully by the time that they're like, a teenager,
right,
they've like, learned a few things because the
right,
parents have, steered them in a
right.
direction,
So
right?
that analogy kind of like hints at like kind of like some sort of learning happening consistently.
I think that would be interesting.
Okay.
Yeah. I think that's like, again, when I think about a lot of these systems, I don't think of them as like static and like, they reset all the time.
Right.
I think a truly intelligent system is one which is stateful, which is very different than the way that like existing systems behave, right? If you go to ChatGPT today, you open up a new chat window,
Yeah.
um, you're resetting your state. Context is erased, right? You have that
Right.
option, right? And is that how these systems should behave? Like, if you imagine if you had an assistant, right, and you know, a human assistant, and every single time you talk to it,
Right.
or sorry, talk to them, like they'd forget, like what everything you told
Yeah.
them
No.
before.
Yeah.
Yeah, yeah.
Yeah. Yeah.
So
But no, we've seen like people like try to build in like memory,
that's
and
right.
I mean, there's like a wealth of like startups trying to tackle that problem
That's right.
itself as well. And so I do think like memory will get built in, but I think I still want to talk about this like supervisor
Yeah,
approach,
yeah,
right? Because I'm curious, like I do agree with you that to get to a full agentic mode, we do need to solve this like problem of like quote unquote like how steerable the model is to do what you want it to do for your very specific
yeah,
task
yeah.
and your industry. So I don't personally, I'm assuming most people are not a fan of just like sitting there and prompting and hitting a button and seeing
For
if it
sure,
works.
for sure.
The supervisor thing is interesting because you mentioned like, hey, like interjecting like or intervening,
Yeah.
right? Is that like a human in your head like intervening, hopping in? Is that another AI intervening and hopping in? What does that look?
I think it shouldn't matter. It
Okay.
shouldn't matter if that signal is coming from a human or coming from like another agent.
Okay.
I think, this whole thing about like agent swarms and things is like, every piece of the puzzle, a human could be there.
Yeah.
But the point is like, how do you abstract the human away from doing like the things that require a lot of turns, right? A lot of like continuous like overwatch,
Yeah.
and allow like humans to be kind of very much at like the supervisor level where their intervention is very sparse.
Yeah.
Yes, I definitely think there will be a world in the future where like many applications or workflows are like completely agentic, right? And
Yeah.
we're already seeing that now.
Yeah.
Right? Um, but that doesn't mean that we should try to obviate the human from the loop. I
Right.
think it's actually more about allowing the human to differentiate, to do things that are much more important in the loop,
Yeah.
that things that they didn't have the bandwidth to do before.
Right.
But now because there's other, components taking care of the other tasks, the human can like, provide the feedback, right? In
Yeah.
in a succinct way, right? But still
Yeah.
be able to steer the end-to-end system. Prompt engineering is like people spend weeks
Yeah.
trying to come up with like the best prompts.
Yeah.
And there's now these new systems that are like these systems can
Yeah.
augment your ability to prompt engineer,
Yeah.
right? You guys of course
Yeah.
do a lot of this too.
Yeah.
Um, I think that's this is the fundamental essence of interaction, right? Like
Right.
again, interaction is not like a system that goes and runs on its own.
Yeah.
It's about like building the right interface so that when you need to intervene, when you need to provide signal
Yeah.
as a human, there is a mechanism for you to do so
Right.
and for you to like be confident that the results that you will get are what you expect.
Right. Do you think it takes away a little bit from the beauty of these models? Like all of this engineering to like get them to do exactly what you want for like very specific scenarios makes sense from like an ROI perspective, but at the same time it's like, hey man, like when we first built this thing, it was meant to say whatever it wants to say, right? It was meant to like make up stuff and like sound smart and reasonable, like just like how I don't know how you're going to respond to me right now.
Yeah.
Like, you know, does it take away from like the beauty of that?
I think it does.
Yeah.
But not in like not in like I'm so disappointed that people are doing this kind of way. I
Right.
think it's more from like you know, it's I don't think we've built the level of confidence that we expect these systems to be able to do things on their own.
Right.
I think that level of trust still needs to be, built. And
Makes
it
sense.
makes a lot of sense why, it takes time to build that trust.
Yeah.
Just like, when two people, interact with each other, it's not like, first time, like, everything is like, perfect, right? It
Right.
takes time to like assimilate. I think with a lot of these systems where there aren't the levels of control or there aren't the levels of intercept that you can provide
Hmm.
that you expect they'll actually behave in the way that you want it to, I think it becomes harder to like build that relationship, right? Build that trust. I believe that like a lot of these systems and, the way that we're thinking about these systems at Cartesia is that like a lot of it is making sure that there are the right vessels that humans can interact with these systems.
Yeah.
That like accelerate, that time to trust, right?
Right.
Maybe I'll use that phrase.
Time to trust.
Time to trust.
Yeah.
Yeah.
Trademarking it.
Yeah. Not. Yeah. I think it's a public phrase. I think folks can use it, but yeah. I don't know if anyone will use it, but
yeah.
I mean, I think like. I think there's something like quite unique about watching these systems like evolve or devolve depending on how the experience goes. And I think that observational aspect of it is very important, right? Because that's the only way you're going to be able to see like, okay, if I let you out in the wild, will you do what I expect you to do?
No, I think it makes a lot of sense. And it's really cool for me because I get to see like, I think I see like so many different ways where people are now building these agents because there's no one right way to do it.
Right.
Like it's the analogy I always like to make, which is like very simplistic, is like if you go build like a React front end website and you go look up, how should I build my React front end website? There's like documented like, hey, these are the 3 best approaches. Right. You need to structure it in this structure. Typically, this is the trade-off of this structure and this structure. The funny thing the exciting thing actually about this new thing is there's no structure. And so I think I've now seen probably like 15 different ways which people have like, gone about building these agents. And they all have like, their pros and cons. And, they intervene in different ways. I think I talked to someone who had like 5 like supervisor agents kind of operating over the main one to like make sure it was working. There's people with workflow based. There's people who say, hey, no, workflows just goes against the entirety of it. I want it to just be the prompt and it's going to keep like being a circular fashion. So it's super interesting, like how these different things interact. Do you guys have a chosen, I mean, with Lion, obviously you guys are there somewhat there, but like, do you guys have like a chosen, like, hey, like this is how we believe the best agents are going to be built? Or are you still thinking about it?
Yeah. I think it's hard to prescribe the exact way something, or like, the recommended way something that should be done when a system is like incredibly bespoke and perhaps, somewhat undeterministic. I think everyone is still discovering this, right? Of course people have built their, maybe a little bit of like more, I guess their work streams, right? Of like how they choose to build agents at like particular companies. But for us, it's actually about, I want to give people the platform to build whatever they want and however they want.
Right.
And so,
how do you make it flexible? That way they can choose whatever workflow and you guys don't define it.
Exactly. Yeah. And that's, I think, again, that is the beauty of code.
Yeah.
Right. Is that, you have that level of it's like just fundamental to code.
Right. It makes sense.
Yeah.
Yeah.
Able to build, when you're able to build in that way, like you show us what you think is best, right? Or what works best for you. Right.
Yeah.
And I think that's a great way also for other people to learn, right? I mean, there's a bunch of these like open source, like, we've open sourced a lot of our templates and, for like agents that we found to be successful. And, I know a lot of other people are doing the same. Hopefully, we can put a lot of that together and, come up with like what are good ways of building, some of these systems.
Yeah, no, it makes sense. So, well, we're getting close to getting back to Cartesia's office.
That's right.
I like to ask a couple like questions. So one question and then some lighthearted questions. So one like larger question is like future of voice and conversational AI, and where does Cartesia stand there 5-10 years from now, in your opinion?
Yeah.
Is just right. Would love to understand that.
I think the future is incredibly bright. I think we've barely scratched the surface of what conversational AI can look like.
Right.
I think, again, the elbow, right, so to speak, of like the voice AI has just been like so steep. It feels like, we're on the up, but like I'm so confident that there's going to be just another pivot that's just going to like increase the slope again.
Yeah. Okay.
I think Cartesia, like our job is to like make sure that
stay
happens.
ahead and you can do it.
Yeah, like be
push for it for yourself.
Push for it, right? I mean, not just for ourselves, but actually for like the whole like ecosystem. Like I think there's just so many things to explore from like a capability side. A lot of these things start with the model. There's amazing work that people are also doing on the infrastructure level and the ergonomics level, like the evaluation side, that you guys are thinking about. That like being able to like be like a catalyst in that ecosystem is very important. And I think, we can provide that. I think that's kind of our focus. And, we're going to keep innovating on the models. We're going to make sure that those are the best for all of our users, right? Including you guys, including new users that, pop up, and, deliver the best capabilities, right? Like these capabilities need to be, you know, built in a way that like, reflect how people want to use these systems and how I think that they'll want to use it moving forward. So that's going to be, our focus.
Makes sense. Makes sense. Does this future involve giving Blue Jay free text to speech?
I think, I'm sure we can work out a nice credit system. Yeah.
I'm just kidding.
No, but
we're happy to pay. I think it saves our ass numerous times, so we're happy.
Well, I'm glad. Yeah. But sorry.
Go ahead.
No,
I have some like completely left side questions.
No, I mean, I think like, a large part of like the ecosystem that we also build is like, how do we just get people to like try more voice AI, right? I mean, we have, I don't want to shill or anything, right? But like a huge part is like, if we're building for developers, let developers try out the product, right? You guys do that too. I think any like, sane developer who has tried products out for themselves in the past, like, look, I want to make sure other people have the ability to like try these systems out. So, we have like, programs for that and to help support like with like grants and stuff if folks are interested in trying out like the systems. Yeah, I guess if you're interested in trying, let me know.
Ping him personally. I'm going to disclose the personal phone number.
It's there.
Send your text, call, email. Cool. Okay. My last questions that I always like to ask is, if Cartesia had a spirit animal, what would the spirit animal be and why?
Interesting. Okay. Well, I don't know if I don't know. I guess it's an animal, but it's animated. It's a Yoshi.
Okay.
It is the.
I don't know if this is an allowed answer. I'm gonna allow it.
Yeah,
but Yoshi's interesting. It's cool.
Okay.
Yeah.
I think for us, it's. I think like there's always been this like internal joke of like the Yoshi, like running, getting things done. I think actually what's pretty exciting is like, it's just something that like I feel like it started as like an inside joke amongst the founders,
right?
But like everyone just like uses this like emoji now in our Slack.
Oh, really?
It's like it just feels like the right.
There you go.
Semblance of.
I honestly, I kind of see it. Like with the logo and the branding, like it makes a lot of sense. It kind of fits. Because you guys have like the blocky thing, and I feel like Yoshi is like, it's like, it just makes sense.
That's right. Yeah, I don't know if I have another spirit animal for you.
Yeah.
But,
I'll take the Yoshi. Yeah. Are you gonna change the logo ever to Yoshi? Do you think at some point?
No, sure that's trademark.
A version of it.
I think that'd be difficult to facilitate. I think they may not like that.
They may not like that. No. Okay. Well, cool. Thanks for joining me
today.
Awesome.
Yeah. Thanks for having me.
Yeah. Awesome.
Sweet, dude.
Cool.